Alright, so we just have a quick video here on normal distribution and those pesky little questions where they ask us to find the mean and the standard deviation. And in order to do that, they'll give us two bits of information. In this case, we're talking about cats. 13% of cats weigh more than 2.2 kilograms. 17% of them weigh less than 1.5 kilograms. So the first thing I do is I draw the distribution for the cats. And I prepared this one a little bit earlier. And you can see here, for 2.2 kilograms at that point, and I've just shaded 13% are more than 2.2 kilograms. Likewise, 17%, so an area of 0.17 lies to the left of 1.5 kilograms. Now, they haven't given us enough information to work on. I know the mean is somewhere between 1.5 and 2.2, but these aren't spaced equally, so I can't do anything about that to find the mean. So I'm going to need to convert them to z-scores. So I've got an equivalent distribution here, and this is my standard normal distribution. Remember, a mean of 0, standard deviation of 1. And I've gone ahead and said the z-score that corresponds to the 2.2 kilograms, that's going to be there with 13% of values lying above it, and the z-score that corresponds to 1.5 kilograms is to the left, and it's going to have, oh, I didn't put the area in there. Obviously, that's going to be 0.17, the area there. And so to find these actual z values, because this is the standard normal distribution, we can use our calculator to do the inverse normal and give us those values. So we go to stats, distribution, and then normal distribution, and we know the areas, so I'm doing an inverse normal distribution. Okay, mine's already set up with the variable on the right, the area on the right. So the area to the right, now if I go back and look at mine, that one there had an area of 0.13. So I'm going to make the area to the right 0.13. So this is going to tell me the z-score that corresponds to 13% of the data lying to the right of this value. Of course, the standard deviation is 1, and the mean is 0. So we go ahead, and it tells me that z-score corresponds to 1.1264. 4 decimal places will usually be enough. Z for 2.2 is equal to 1.1264. Yeah, 1.1264. Now I want to do the same thing for the z-score corresponding to 1.5 kilograms. I'm going to use my calculator to find that value. Now I could just say, keep it to the right and say 0.83, because obviously if 17% is to the left, 83 would be to the right. But I'm just going to make it easier for my brain. I don't want to accidentally make a mistake doing maths in my head in the exam. So if I've got the opportunity to use this, I will. So I've now got the area to the left is 0.17. Still my standard normal distribution, standard deviation of 1, mean of 0. I'm going to calculate that. And it's going to tell me negative 0.9542. Negative 0.9542. So we've got our two z-scores. Now you can set up simultaneous equations here using your z-score rule. So the z, remember our z-score rule is z equals a score minus the mean divided by the standard deviation. So I'm going to have two equations. I'm going to have negative 0.9542, and that's going to equal the actual score for that z-score, which is 1.5, minus the mean divided by the standard deviation. And I'm going to have another equation, 1.1264 equals 2.2 kilograms minus the mean divided by the standard deviation. And here we've got two simultaneous equations to solve. If I rearrange them to get them in the form that our calculator needs, when we want to use solver, so if I go to menu and equation solver down here, simultaneous equations, two unknowns. So we're going to have ax plus by equals the constant. So I'm going to need to rearrange these a little bit. I'm going to have negative 0.9542 sigma equals 1.5 minus mu, and then that could give me, so sigma didn't look quite like a sigma, it looked like a 0, and that then gives me the equation mu minus 0.9542 sigma equals 1.5, and similarly I've got 1.1264 sigma equals 2.2 minus mu, and adding mu to each side, mu plus 1.1264 sigma equals 2.2. And from here, I can use my calculator to solve these. So I've got 1, negative 0.9, goldfish number here, 542. Oh, negative 0.9542. Press enter, that might work better. Equals 1.5. And then the other one is mu, so 1 plus 1.1264. 1.1264 mu, and that one equals 2.2, I believe. Yeah. So I go ahead and put that in, and then we click on solve, and that's going to give me my two different values there. So we've got, I'll take a screenshot of that and add it in anyway. So we go ahead and we do that, and so we've got mu is listed first, so the average weight equals 1.821 kilograms, and the standard deviation is 0.3364 kilograms. And we double check, and I'm sure they tell us about, ensure your final answers are written in separate lines rounded to 4 decimal places. They've given demonstrations there, and they're not the actual answers, but I didn't write the other one to 4 decimal places. I have to go back to my calculator, and I can actually read off here. 1.8210. I need to write the 0 to make sure I've written it to 4 decimal places, and the 0.3364, make sure they're not rounding that. Yep, 0.3364. And there we have it. That's how we go about doing those questions. I will show you just one other way of doing it. Once you've identified the two Z-scores, so the negative 0.9542 and the 1.1264, there is an alternate method. We can just say that this 1.1264 minus, so when I'm finding the difference between the Z-scores, so because this one's a negative, we'll actually add it together to find the total difference between the Z-scores. If I take those coefficients, that's how many standard deviations apart these two scores are. So that number times the standard deviation is equal to the difference in the weights of the cats. Now, it's not necessarily obvious that this is always the case. It is the case. But if I do the difference in the Z-scores multiplied by sigma equals the difference in their weights, I can very quickly find sigma that way as well. So it's going to be 0.7 divided by what we get when we subtract those two. So I'm just going to write it as 1.1264 minus negative 0.9542. And if we do that on our calculator, that should tell us the sigma value as well. So we'll go into our run menu. So we had 0.7, which was the difference in the weights of the cats, divided by brackets, I'll get there eventually, 1.1264 minus negative 0.9542, is that right? Yeah. Oh. They were supposed to be brackets. And we get 0.3364. So that's another way you can do it. Personally, I just find the simultaneous equation seems to work well for me, but you can just say, well, the difference in the scores is equal to this multiple of the standard deviation, so it should give you the same answer. And so you've got your sigma, and then you could substitute that back into either formula to find the mu. So you've got a second way of doing it. I hope that helps. Good luck with the revision. I'm sure you're going to do fine. Cheers.